Hello everybody, welcome to the Tech Talks for this week. Today we've got Lars Rosenquist from Redis Labs. Lars is going to tell us about a story. He's going to go through a story about how COVID's changed consumer behaviour, how it impacted retailers in particular, and how they were presented with some strategies and some solutions to, instead of just helping keep their head above water, to try and look at some of the changes in behaviour and sniffing out and helping them to understand what opportunities might be presenting themselves. I'm sure Lars has got a much better explanation of that than I have. Lars is, according to his own bio, an experienced software development veteran with over 20 years experience in the industry. You should talk to me then. Before he joined Redis as a partner solution architect, he did 3 years at Pivotal and VMware. And for 17 years before that, he worked in software product development. Okay, so without any further ado, I'll hand over to Lars.
All right, folks. So my name is Lars Rosenquist, and I'm a partner solution architect at Redis Labs. In case you have any questions after the presentation, or you want to reach out, or you have any questions at all, you can always reach me at my email address over here, or at my Twitter handle below over there. So be sure to reach out in case you have any questions. Today, I'm going to be talking about how Redis is driving the world of modern software. So what are we going to be talking about today? So I'm going to talk about how COVID-19 disrupted the retail market. And I'm going to talk a little bit about how consumers and companies responded to this disruption and how they transformed their behavior. Third, I'm going to talk about how Redis helps accelerate that transformation. And last but not least, it's not all going to be slides. I'm also going to be showing some actual working code and a demo. So, COVID-19. Who led the digital transformation of your company? Was it the CEO? Was it the CTO? Or was it COVID-19? I mean, we've all seen this joke pop over 1 million times over the past year or so all over social media. And it's a joke, or is it? I mean, it's pretty much a fact that a lot of companies were already in the process of doing a digital transformation. Some of them were a bit further ahead of that in that than others. But COVID-19 definitely had an impact on these transformations and started accelerating them. So what was COVID's impact on consumers? What we have seen is that when the pandemic struck, customers started to spend their money in different places and in different ways. So what we've seen is that the estimated retail spending as a percentage of household expenses dropped from about 34% pre-COVID to 23% during COVID. Consumers also expect that number to rise back up a little after COVID has passed. We've also seen on the spending online side, we've seen the reverse actually happening. So the estimated online spending as a percentage of total retail went from 38% pre-COVID to around 73% during COVID, and it's expected to drop down again to about 47% after COVID. So what we can see here is that consumers, that they anticipate a post-COVID rebound in retail spending, but it won't drop back down to pre-COVID levels. The same thing for the online spending. Consumers expect a post-COVID regression in that area, but they still expect it to remain well above pre-COVID levels. So what we see here is that COVID has a lasting effect on consumer behavior and where and how they spend their money. And of course, that's the thing when you have this crisis situation that lasts a very long time, it impacts your behavior. And because it lasts so long, that behaviors become habits. And that means that the effect is a lasting one.
Sorry, Lars, just one quick question there.
Sure.
Chris is asking where have those retail numbers come from on that previous slide?
Yeah, that's a good question. So I don't know if you can read it, but it's from the Consumer Insight survey by the IDC info brief. I can link you to that report if necessary. So I didn't make them up.
Thank you.
All right. So one of the things that we see is that not all segments in the market are impacted equally. There are winners and there are losers. So we can see that the essential segments, they saw a small amount of growth during the pandemic. So it accelerated a little bit from low single-digit growth to about 6 to 8%. In the non-essential segments, however, that was absolutely the other way around, where annual sales are expected to be 10 to 15% less than the previous year. E-commerce, however, saw, of course, a whopping growth, about 15 to 20% overall. We also see that different segments are sort of facing different challenges, and whether they can deal with those challenges or not really depends on their digital maturity. So we see that 82% of retailers with an omnichannel presence, so retailers who also have a presence online or in other channels, they saw a larger than 6% increase in profitability. 72 or 27% saw an increase of even over 10%. So how did customer behavior change exactly? So here's a couple of examples. First of all, consumers, they show a strong preference for spending as little time in the store as possible with as few interactions as possible. I mean, before COVID, this was already starting to happen, right? People were already ordering a lot online. But I mean, with the pandemic raging around, customers, they don't want to stay in a place with a lot of people for a long amount of time. So what's happening is that customers are consolidating their trips. So they go to the mall or they go to the store once, and then they buy all the things that they need rather than taking individual trips to different stores, which means that larger baskets are now in play. Furthermore, we see that consumers show a strong preference for contactless payments. And not only that, whether contactless payments is there or offered or not by a retailer has a significant impact on where they will spend their money. So we see that around 59% of consumers will likely shop elsewhere if the retailer doesn't offer the ability to buy online and pick up in store. We also see that roughly half will go to somewhere else if there is no option available to buy online and pick up on the curbside. 51% wants to have the flexibility to return purchases made online in the store or vice versa. And 48% wants to have some visibility into inventory and costs before they buy. And that's, of course, logical, right? I mean, if you want to go to a store, it's really great if you can check online whether the thing that you want to buy is actually there or not, because if it's not, then you can go to a different store. On the topic of contactless payments, we see that, I mean, it's still a very large percentage that either doesn't really care about contactless payments, about 30%, or people that do prefer contactless payments but won't let it affect their decision. But no less than 24% of consumers say that they will only shop at a retailer that offers contactless payment options. And if it's not offered, they will go shop somewhere else. So how are retailers reacting to those changing customer expectations? We saw that when the pandemic struck, that the initial focus was, of course, on crisis response, on survival. I mean, for some of these retailers, and not just in retail, also in other lines of business, the world changed overnight. I mean, with lockdowns being put in place, stores being closed, but also, I mean, airports being closed, air traffic dropping, there were a lot of changes, and a lot of companies faced a lot of trouble just staying alive, let alone work with the current situation. On the other hand, we also saw a lot of companies who quickly shifted from survival to adapting to the current situation, and sometimes even using the current situation to their advantage and accelerating their business. So what we see is that there's a shifting technology investment in response to the pandemic. So about 32% of retailers surveyed said they invest in technology projects to respond to the crisis. So they're having projects to reduce operating costs and also to respond to the crisis brought on by COVID-19. Around 31% has invested in technology projects to address areas that were revealed as a weakness during the COVID-19 pandemic. You can think of a retailer, suddenly, let's say their physical stores are closed down, everybody's going to the website becomes slow, goes down, right? So those are sort of weaknesses that are being shown and that needed to be addressed during the pandemic. Furthermore, we see also in adaptation, we see that there are projects that support the new operational requirements brought on by the COVID-19 pandemic. I don't know how it is in the UK, but in the Netherlands, you can right now go to a store, but there can only be 2 people per certain square meters. So companies need to organize that. So you need to plan your trip. You need to actually reserve a spot before you can go to the store. So how do you set that up? That's a matter of logistics, but it also means that applications need to be built, websites, customers need to be informed, they need to be able to call, all kinds of processes need to be put in place in order to support those processes. The problem is, of course, that all these restrictions, I don't know how it goes in the UK, but in the Netherlands, they sort of pop out every minute of the day almost, right? So one day, customer or retailers have to deal with one situation, and the next day that situation can be completely different. Furthermore, we see that about 32% of retailers is investing in projects that can help them capture additional market share or can introduce business model innovation, so new business models based on the global pandemic. I mean, if you look in Europe, I mean, who bought face masks before the pandemic? Nobody, and now you can find them everywhere. So there's a crisis, sure, but there's also lots of opportunities for lots of companies in that area. So how does the new normal look in terms of applications and in systems that are being developed? So like I said, the ability to be able to respond to those changing measures and restrictions that are being put in place or lifted means that companies need to have a certain amount of agility to be able to respond to that. So there are a couple of key components in order to make those changes. First, your data and the data that you have needs to be actionable, so you can use that data and meet the customer where they want and what they want to buy. Second, your systems need to be resilient. So whenever there's a restriction put in place or it's lifted and there's a sudden inflow of users or outflow, your systems need to be able to deal with that. So in one case, you need to be able to adjust to the peaks. In the other, you need to sort of be able to scale down in order to not spend too much money in case of slow time. Furthermore, workforce transformation. Of course, as we've all seen, is that now everybody's working remote. A lot of changes were needed to make that possible. And also in the post-COVID world, we will see that there's also going to be a lasting effect over there. So what we're seeing is that 35% of retailers are investing in technology to close the gaps in digital transformation, and they've got 3 business priorities. So priority number 1 is to create a data program to gain insights in their business operations, products, and our ecosystems. So taking that massive amount of data that they already have and putting that to good use and making use of that as efficiently as possible. 43% is investing in resiliency programs, and 41% is investing in workplace transformation programs. I've personally spoken to banks. I mean, that's not retail, but I've personally spoken to banks, and they said already that they moved their entire workforce almost remote. And they already said immediately after 1 or 2 months in the pandemic, they said to me, and they said, Lars, we don't know exactly how the post-COVID world is going to look, but we do know that it's not going to look like the same before COVID. And you can think about, for instance, real estate, right? These companies have massive amounts of real estate in order to house all those employees. Now they can see that they no longer need that. So they don't know exactly what it's going to turn out to be, but they know that their workplace and the way that people work is transforming. So some of the top goals. Like I said, companies want to be able to consistently deliver against that rapidly shifting behavior. So if the government decides to announce a new restriction tomorrow, you want to be able to handle that, and you want to be able to respond to that very quickly. Second, they want to create a strong customer experience and drive long-term loyalty. Like I said, customers, larger baskets are in play. Customers are being more, determining on sort of where they can shop, and customers also have more options. So you really want to make sure that you can tie those customers to your business so that they will return. So one of the top actions that they're taking is to deliver those foundational data capabilities. And I'll go talk about that a little bit more in detail after these current slides. What's important for them is to create data transparency and real-time availability across all channels. So it doesn't matter whether your customer starts in the online channel and then moves to the retail channel or vice versa. You want to make sure that they always have the accurate data available in real time. Furthermore, you want to have the speed and efficiency for analytics. So we don't want to, let's say, ingest a lot of data and then at the end of the week run a report for 3 hours and then get your information. No, we want to analyze that data as it is being ingested, and we want that information to be available straight away. They're also going to modernize their existing application portfolio. Not all the existing applications that are in place already are being suitable for this kind of agility or the amount of online load that are being needed. So they're really looking at modernizing these existing portfolios and bringing them into the future so that they can still be leveraged and still be used. Some of the challenges that they are facing is, well, of course, slow or offline apps or websites. With customers having the choice, I mean, if your website is not working or it's showing not the right information, customers are just as easily going elsewhere. It's that easy, especially when customers are having things delivered. For me, it doesn't really matter where I order a certain product, as long as it's delivered to my door tomorrow at 8:30 in the morning. Limited or inaccurate view of inventory and other data. Yeah, like I said, I mean, if I want to make a trip to the store, I want to know right now whether the thing that I'm going to get is available on that specific location or not. If it's not, I can go to a different location. If the store doesn't have it at all, I can go to a different store. Misidentifying customer segments. So this is really about sort of being able to identify who your customer is and what kind of segments they belong to, so you can present them with relevant recommendations. Keep in mind, customers have a lot of choice. That also means that small barriers are going to carry a great risk. And we can see this innovation going on in the entire industry. That means that everybody is going to innovate in that sense. So customers really have the choice. So if I need to buy product X, I can go almost anywhere. So even if there's a small sort of barrier, that can pose a massive risk. I can speak from personal experience, sort of like I grew up in the 70s and 80s. So I mean, you can't see I have gray hair, but I do have gray hair. I'm still sort of in awe of technology, and I sort of have patience with certain technology when something works. But if you look at my children, for instance, they grew up with this technology and they have no patience at all. They just expect this to work. So even a small barrier, even if it's half a second more response time or a second of response time, can make them go somewhere else. All right, solving the challenges. So what do you really need to build that foundational data layer? So you want to build that seamless customer experience across channels to make sure that a customer can maybe start their customer journey at the safety of their home from behind their computer, and then can continue it in the retail store or vice versa. Like I said, the accurate inventory and other information across channels, make those available. Furthermore, existing supply chain, inventory, e-commerce, and retail channel systems, they must be integrated seamlessly. And we want to show the right data at the right time in the right place. So real-time response and super low latency. Shopping cart, user, and purchase history data has to be available across channels. And we want to have a real-time overview of the available inventory. Always on, also important. So no or extremely limited amount of downtime. If your system is down, customers are going to spend it elsewhere. And of course, scalability. So you want to be able to withstand those peaks, but also during the lows, you want to be able to turn off those resources or scale them down so that you don't break the bank. Data is only part of the story, though. So when we talk about digital transformation, we're always talking about data and applications. That always goes hand in hand. So we're talking about modern data and modern application architectures. So you want to leverage architectures that allow you to release quickly, securely, and in a way that it is resilient and it has a certain level of quality. So we're talking about not just traditional monolithic architectures, but also microservice architectures or more modern event-driven function-based architectures. And again, modernize that existing legacy application portfolio. Don't throw it out just yet, and I'll also talk a little bit about that later. But modernize it so it can fit fit the needs for 2021. Also, leverage the public cloud as much as possible. Don't reinvent the wheel. So don't spend a lot of effort in building out your own platform, right? So there's a lot of talk around Kubernetes and installing Kubernetes and all kinds of other platforms. Well, unless you are a company that's selling platforms and making money on that platform, and some retailers do, right? I mean, Amazon offers a platform to other retailers, and we have in the Netherlands, for instance, bol.com, who does the same. But those are pretty much the exceptions. They have a platform and they've got money coming into that platform, so they can afford to invest in that. But if you're the only customer of your platform, build features rather than infrastructure. So get this infrastructure from somewhere else and make the management somebody else's problem, but not yours. Change the way of working. So modern architectures require modern organizations with an adaptive way of working. Remember Conway's law, right? So your application or your system landscape will mirror your organizational landscape. So if you want to have a modern application or systems architecture, you want to make sure your organization mirrors that, or it won't work. Another way is sort of let the data drive the experiments that you do. So for every change that you make, form a hypothesis and then verify that hypothesis based on the data. So form the hypothesis, make the change, check the hypothesis, and then make a decision. Did it work? Yes, keep it. Did it not work? Okay, try something else. Always make sure that your data is sanitized though, because it's very easy to be biased when it comes to data. So there's all kinds of bias, like survivorship bias or other types of bias that come into play when you're dealing with data. All right, I'm gonna pause here for about a couple of seconds. First of all, to take a sip of my cola, and maybe there are some questions already.
Anybody got any questions right now? And you don't need to restrict yourself to the presentation. You can question how Lars got that magnificent lighting set up in his little office there, because when I was chatting to Lars on Monday, I thought it was amazing. So, you know, feel free to put any questions about the pink lights in the chat as well.
Yeah, and the musical devices that are present, it's perfectly fine to talk about that as well. I'm not giving a demo of those today, by the way.
Yeah, as I said before we started the call, Lars is the only man that I know of that goes into meetings, important business meetings, and changes the background to tone it down to make it look less interesting.
Absolutely, absolutely. Yeah, I also change the color depending on the company that I meet. So if I'm going to meet with IBM, it's going to be all blue. If I'm going to meet Oracle, it's going to be all red.
Excellent. Okay, well, no one's chiming in with any questions, Lars. So if you want to carry on, please do.
Excellent. So we've talked about the IDC report and some of the findings in there and some of the challenges that companies are facing. So how does that fit with Redis? How does Redis Enterprise help in this case? So let's go over a couple of diagrams. So the first thing that we talked about is having real-time access to all that relevant data and content. And this is typically the traditional use case for Redis. Redis used to be regarded as a cache only, but these days we really look at Redis as being an in-memory database and being the platform for all your data. So how does that look? So if we take a look at, and this is a very high level picture, of course, where you have a landscape where you have maybe applications that are built for mobile shopping, or applications that are built for shopping on the web, or maybe there's retail applications that are being used in physical stores. And they all integrate with these existing or external systems or existing data stores and existing file systems. So the typical case for Redis is, because Redis is based around performance and it's being built around speed and a high number of concurrent operations, it's best to have your applications integrate directly with Redis. So read from the cache rather than reading from the systems directly. Of course, that's not always possible because sometimes data is not there yet. So in that case, you need to read the missing data from the source and then cache it. And on the way back, you do the same. You write to the cache and you write to the data sources if necessary. By having a consolidated data platform, you will get a number of capabilities. So first of all, you can have shopping carts and user sessions real-time and cross-channel, and you can really make sure that that data is present across all channels. Especially if you're deploying your applications in this layer, if those are stateless applications deployed on something like Cloud Foundry or on Azure Spring Cloud or on Kubernetes. It's not just for those types of data that I just mentioned, it's also for content. It's also one of the big use cases for Redis, right? To cache things like images or other data. So you can also cache your product and inventory data. What it also does is it relieves your backend systems of the stress of the online load. So Redis is really being designed, and it's being designed with performance in mind, so it can handle those big waves of load that are being sent to your stores, while your legacy backend systems may or may not be able to handle that. And by having a data platform in between your existing systems and your front-end applications, you can really make sure that these existing applications get some breathing air. It will also reduce downtime. I mean, Redis is known for its stability, and especially if you deploy it in an active-active configuration, you can go all the way up to 5 nines of availability. So that's usually a lot better than what a lot of legacy systems can deliver. Of course, that's the traditional use case for Redis, but Redis is really much more than just a cache. Because we don't want to just provide data in real time, we also want to provide it in the right place and with the right localization. So if we take the same situation again and the same setup where we have different applications spread across different channels, and you have your data platform happily serving your data for, let's say, maybe you have some web shop users that are based out of the UK and they want to access the data. But what if I have other users present in other parts of, let's say, maybe Eastern Europe or Southern Europe that also want to shop in your retailing, and they also want that same fast access to data? That's of course possible, and one of the features of a Redis Enterprise is that you will be able to do this active replication of data. So data is replicated, not just in an active passive way, but in an active way. And what that means is that users on both sides of the fence can do both read and writes, and these read and writes are being resolved in a conflict-free manner. Again, you can do the same with other continents and replicate your data over there, or you can even deploy Redis Enterprise at the edge. So deploying it locally in the store to have the applications in the store interact directly with that data in a very fast way, instead of having to connect to some central service that maybe is geographically a lot further away. Redis Search is a module that can be added to Redis. So typically Redis, in the normal or in the basic setup, Redis is really just a key value store, but it doesn't offer a whole lot to do with that data. This is where modules come into play, and Redis Search is one of these modules. With this module, you can do full text search, even phonetic searches across all your types of data. You can then combine that with geospatial index data in order to provide data for customers relevant to their local geography. So you can serve customers data relevant to their geography and location, but you can also serve customers data from their geography and location instead of having to deal with high latency. Because you're scaling out, it also means that the availability significantly goes up. So it goes all the way up from 4 nines up to 5 nines. And basically, this gives you the capability to have real-time access to data anywhere. But that's not all. There's still more. We also want to provide data with the right context for the customer. So again, if we take the same setup, where Redis is acting as the central data hub for all your online applications, there's also a module called Redis Graph, and this will add graph database capabilities to your existing Redis setup. So a graph database is different from a NoSQL database in the sense that, and it's also different from a relational database in the sense that you can really type those relationships. So you can really tie certain products or maybe certain branches of types of objects together and say something about the relationship that they have with each other. You can then have a module like Redis AI to make intelligent decisions around those relationships. So when somebody has ordered something, you can say, hey, maybe you want these other products that are also associated with this product to go with that in your next order. So, and with Redis AI, you can tap into some of the most used frameworks that are being used out there. Last but not least, real-time analytics. So Redis time series, that's another module that's present. And that will allow you to do that real-time analytics. So it gives you the capabilities to build things like search and purchase history, do things like personalization, being able to identify those customers and those customer segments, and provide that real-time analytics with low overhead that you're used to, from Redis, right? So it doesn't take hours or days to get the results of those queries. No, those are delivered with the same sub-millisecond latency that you're used from regular Redis. And you can do things like recommendations. I mean, if I bought a toilet seat from Amazon, the last thing that I want is to, for the upcoming month, is for Amazon to recommend me to buy more toilet seats, right? We want to have some sane recommendations for those kind of cases. But wait, there's still more. So we talked about those old aging systems that are being used, and we usually call them legacy systems like it's something bad, but a legacy is actually something good. A lot of times these are applications that are making a lot of money for businesses. So do we want to throw them out? Maybe there are better ways that we can do with that. So again, if we take the same setup and we look at Redis, there's this thing called change data capture, which is a pattern that can be used to synchronize changes from your existing systems. So that means whenever something is changing in a database, that change is propagated via CDC into your existing data platform in real time, and vice versa. By making use of Redis streams, you can then stream these changes directly into your client-facing applications. So that means that whenever there's a change occurring in a remote or in some downstream system, the change will be automatically propagated through your data layer and into your applications via streaming. So some of the capabilities that you will gain with that is the capabilities to build those reactive real-time applications, make use of modern technologies like event streaming, and have real-time synchronization with legacy system and stores without making too much changes to those systems that are in place already. And that way you can build on top of that legacy rather than replace it outright. And maybe you do want to replace it outright at some time in the future, but this gives you a lot of breathing room to keep working with these existing systems. All right, I'll take a short pause again before we go show some actual live demo action.
Lars, I've got a quick question.
Sure.
So earlier on, there was a slide where we were saying how that you can put some writes into the database, into the Redis thing at the same time as you're writing into the underlying data stores, right? So to update the cache in response to something that might happen, say in a shopping cart or something, presumably to make sure that the same thing isn't bought twice, which seems sensible. How does that look? I'm assuming that there isn't an actual database transaction going on there. So is there some mechanism that goes on to ensure consistency of that data, or is that something that has to be managed outside of the Redis tools?
That's a really good question. So when we talk about active-active replication and you're doing writes on both sides of the fence, so to speak, that's where conflict-free resolution data types come into play. So the data types inside Redis, they take care of that, of resolving those conflicts. So internally, it uses a mechanism called vector clocks in order to make sure that that each Redis instance can know which change of data took place in which part of time, and it can decide which transaction will win in that sense.
Okay. It sounds like a whole subject in and of itself, actually. So
yeah, definitely. So definitely look it up. So if you want to know more about that, it's CRDT, so conflict-free resolution data, resolving data types.
Yeah.
So definitely, and I can also forward you some information about that because it depends on the data type on how the resolution is done exactly.
Okay, brilliant. Thanks for that. Okay. Anybody else got any quick questions now? There's a question in the chat. So Natalie is asking, it would be interesting to know what the AWS or Microsoft equivalent or something similar is to Redis, and why retailers would choose Redis over one of those, or are they used together?
Yeah, so that's a good question. So it's good to know that let's say we do not compete head-to-head with those parties you just mentioned. So if we look at, say, for Azure, for instance, if we look at Azure Cache is actually, it has several tiers. So it has several open source Redis tiers, and it has several enterprise tiers, which are being developed together with Redis Labs. So that means that depending on the use case, if you don't need things like those enterprise features like the modules and the active replication, because that's reserved for the enterprise tiers on Azure in this case, you can do with a lower tier, for instance. So in a sense, we're sort of competing with our own product there, right? So we have the enterprise product that's competing with the open source product, but that's fine. Depending on your use case, you should always pick the one that fits best. We have similar constructions in play for other cloud providers. So in Google Cloud, we also have a marketplace. Google also has their own cache implementation called Memory Store. Mm-hmm. But again, compared to the enterprise version, there are certain advantages and drawbacks to using that. So it's both a competitor, but it's also a complement. So in some cases, you will use Memory Store. In other cases, it's better to use Redis Enterprise. And the same is for AWS, who of course are using Elastic Cache. But there it's the same. So the offering that we have will offer certain advantages over using the Elastic Cache, and vice versa.
So like anything else, it sounds like there's going to be a version that's in Azure, which is basically just a hosted version of the thing with no extra stuff added on, and there's various different things. It sounds like there's a similar picture elsewhere, right?
Yeah, definitely. And you can check that out. If you check out Azure Cache for Redis, then you can see the different tiers. So there's a basic tier, which is basically box standards, open source Redis, and it goes all the way to enterprise and enterprise flash, which allows you to extend your RAM memory with flash memory to really use those large data sets.
Okay, well, that's answered one of the questions I had noted down, but we might come back to that. Jim Burke is asking, how configurable is the streaming feature to apps? Does it have something like a pub sub model?
Yeah, definitely. So there is pub sub functionality in Redis as we speak. So that's really a traditional pub sub model. The streaming feature is actually a bit more powerful than that. So if we look at the pub sub model versus the streaming model allows you to tap into a stream and get everything. Whereas if you're using a pub sub, yeah, anything that happens before the subscribe, you no longer have access to that. So there are differences in that, but you can do both. So there's a pub sub model and then there's the streaming model. And I can send you some detailed information on how that looks and how that works exactly and what the exact differences are.
Okay. All right, I think that's covered all the questions for the moment. So let's have a little demo. Thanks, Lars.
All right, let's take a look. So I'm going to tell a retail story about beer. So I thought that was a good subject for the Friday afternoon. So that's let's see what we got here. So the source of this demo can be found in the following GitHub repo. So you can also check the code out yourself and then run it yourself. So simply follow the README to run it. So let's take a look at the demo itself. Let me move this out of the way. All right. So I'm going to be showing a real-time inventory demo, and it's going to be based around the following architecture. So typically in a retail architecture, we have various systems that are generating various events, which are then being sent to the inventory manager, who manages the inventory and then exposes it to different other systems. What are we going to show in the demo? So I'm going to show you a retailer called Brutus, which is a beer retailer, a virtual beer retailer, of course. It's based around the information in the brewery DB. So that means there is about 3,500 stores available and around 30,000 SKUs. What I'm going to be showing is the product catalog, the item availability, and the real-time inventory. It's based around a pretty simple data model that features product, stores, and inventory. And then before I will start the actual demo, or before I show you the actual demo, let's actually start it. So if you checked out the demo from the Git repo, can everybody see this all right, or does it need to be bigger? I think this will be about right. So after you checked out the demo, all you got to do is a Docker compose up, and it will start the application. So while this is starting and it's populating all the data, let's take a look at some of the structure of the demo. So if we look at the structuring of the application, so there's a data loader that is started at the start of the application that's responsible for loading all the test data and makes it available to Redis Search, which is then being exposed via a web application, which is a Spring Boot Java application. And that via WebSocket connection updates that information in real time in the user interface. Furthermore, there's an inventory generator and a restocker that are operating on the update stream in the background in order to create some dynamics around the inventory. So let's see how that looks. So if we take a look at the application, it's pretty simple. It's a pretty simple concept. So we have the Brutus application. It has three main features. It has products, availability, and inventory. So in the search box, we can search for something. So we can type something like, let's search for Chambly. So you can immediately see, and you can see how fast it was. Of course, that is of course always fast if you're running it at localhost. But you can see that whenever I search, you can also see that searches are being highlighted. This is actually a feature of Redis. So Redis can highlight the search. When you search something, it can highlight the features that it matched. So when we click on the details, you can also see that it matched over here on Chambly.
So Lars, I've just looked at the underlying data store on which is brewerydb.com. So this is real brewery data, right, from around the world?
Yeah, it is.
So, has it got Brewdog Hazy Jane in it then?
Brewdog. Well, that's
yeah, Brewdog.
What do you say, Hazy Jane, like that?
Yeah, Hazy Jane.
There it is.
Nice.
There it is.
That's their old branding though on the Hazy Jane label. Never mind. That's not down to Redis. That's down to the underlying. That was quick. Yeah, nice.
Yeah, that was nice off script. So I was lucky it was there. So let's take a look. So let's take a look
at the. Just checking that it was genuine data, just to check the. No, that's brilliant. Thank you.
So the product data is genuine. The inventory is probably not, right? So. Like I said, you can also do sort of phonetic search. So if we search for Chambly, let's say I don't know how to type Chambly, so I just type it the way that it sounds. You can see that it also works. You will also notice that there's no highlighting here, but if I go into the details, there's highlighting over there. And what's the reason for that? The reason for that is when the index was created on the products, and here you can see the Redis command that was used to generate the index. We can see that it created an index based around SKU, name, and description. And the name is just text, but the description actually has the phonetic search enabled on the index as well. So that is what gives you the ability to search phonetically, and that's why it can still match the Chambly in this case. So if we take a look at the availability of the Chambly, you will see that I am located in New York, somewhere in the harbor, I think, and you can see that there are 3 stores that have this beer on stock. So if we go over here and we go look in the stock of the application, we can see it has a couple of beers on stock, and you can also see some of the lines updating, and I'm not doing anything. So look, no hands. So that's actually the stock being real-time updated by the process in the background. So people are ordering this, and the inventory manager is responding as we speak. So that's all happening in the Spring Boot application, and these changes are then being streamed via the WebSocket connection into this Angular application. Now, like I said, I mean, this is not the greatest UI in the history of UIs, but it pretty much does the job. What else can I show? So we can also do some search filtering. So in this case, we can also do food pairing. So let's say if I want to go beer that goes well with beef, well, then we can search on that, and it will give us a lot of beers that go well with beef. Or we can do it with salad or with fish or barbecue or whatever. In this demo, let's say these search features, these food pairings are being added as sort of an extra aggregation or an extra text fields on the search data. However, you can also imagine, what if I have a store and beef is an actual product in that store? So you can then use something like a graph to display, hey, this type of food goes well with this type of drink. So in this case, the 2x APA goes well with, I don't know, a Wagyu steak or something like that. I don't know. I don't know whether these actually go together, by the way. But you can do lots of interesting things in that. Or you can look at somebody's purchase history. So if somebody bought IPAs, I mean, I gave the example of the toilet seat earlier. There's very little chance that if I bought a toilet seat last week, that I want to buy another one this week, unless I did some really strange things. But if I bought beer last week and I bought it again the week before that, and the week before that, chances are pretty good that I want to order that beer again. And if I'm going to order a beer, maybe I also want something to go along to eat with that. So you can do a lot of interesting things with these kind of searches. We can also search for the brewery, for instance, and you can see also that it's auto-completing, right? So whenever I type something, we can see that it's immediately searching in the search index, and that the data is being displayed almost instantly.
Have you got any Mad Squirrel brewery stuff in there?
Can you repeat that?
Mad Squirrel.
Squirrel.
Yeah.
Let's see.
Mad. Oh, I'll have to add them to the database. It's a local brewery to me. It's just up the road.
Ah, they didn't put that in. Yeah, I think. Yeah, so I'm not sure if all the European breweries are also in this database.
Yeah, again, I'm looking at Brewery DB now. I've got some of them. I'm glad you've introduced me to the Brewery DB site. I'll be checking it out from time to time now.
Excellent. So again, if we can also go to the inventory tab, and there we can see the entire inventory of beers. So there we can see all the beers that are going out of stock, and also the beers that are, well, apparently there's a lot of stock, so maybe it's not that popular. All right, so that's the application. Let's take a look at sort of how this thing works and what makes it tick. So let's go into some actual code. So what we've got here, we've got the Brutus product that's being checked out. Can I make this a little bit bigger? There we go. Now it's a bit readable, better readable for everybody, right? It has two main modules in it. So there's the Brutus API, and this is your typical Spring Boot application. So what you can see here in the application, and it's a pretty standard Spring Boot application. It doesn't have a lot of dependencies. It does have a couple of very interesting dependencies that are being used there. So first of all, it's just using the standard Spring Boot starter web and the WebSocket dependencies. And then it uses something like the data Redis reactive. So that is the reactive version of the Spring Data Redis dependency. And we also introduced something like Redis search. So what you saw earlier, so when you can create those Redis commands, like the creating of these schemas, this is really how the Redis client is based, right? It's text-based, and you enter all these commands. The good thing about the libraries that are being important here is that it now gives you an API to use those search queries against the Redis connection that you have available. So you don't have to worry about it. It's a little bit like having a criteria API for Hibernate or something like that, right? All right, so if we take a look at the actual application, we can see that the Spring Boot application, yeah, again, this is a fairly bog standard application. It has scheduling enabled to enable the processes on the background that are doing all the inventory updating. There's a data loader that loads all the data in the Redis instance. So it's loading the stores, it's loading the products. And we can see here that it's loading these products and stores into the database. And first, it's creating those indexes, right? So it's building those indexes right here. So it's basically on a description. There's a field called address and some other fields that are being in there. And the same thing is being done for the products, right? So these are all pretty, yeah, it's pretty simple. Files being read, and it's then being added into the Redis instance. Another interesting thing is the inventory generator. So this is the one that's responsible for creating all those fake inventories in the stores and managing that. Again, this is a component that's being scheduled using the internal scheduler by Spring, and the rate at which it's being generated is configurable. So this is really where it's updating So here we can see that it's updating Redis via the stream, and it's adding the update stream. So furthermore, we can also see that there's a web controller. So this is I'm sorry about that. It has a couple of methods for retrieving the products that we just saw in the UI, and also to be able to retrieve some of the styles and categories, and also to be able to retrieve the inventory, but also the availability. And what you can see here is this is where the longitude and the latitude comes into play, right? So every store has a geographical location attached to it. And by sending our own location from the browser in this case, so the browser, who thinks I'm in New York, by the way, while I'm actually in the Netherlands, it sends a location across the API towards the method over here. And then you can simply ask Redis, hey, give me all the stores within X miles of my current location, or within X kilometers of my current location, or give me the distance to the nearest, or something like that. Those are all kinds of queries that you can ask Redis, and you will get those answers at the same speed that you're used to getting all answers from Redis. So those are some of the methods that are being in place, and you can see there's very little code being needed, especially in order to deal with the streams and stuff like that. A lot of that is handled under the hood by Spring Data, which is great. I always consider Spring Boot to be sort of a double-edged sword in that area, because it's really great to get started, because you have to write very little code. The drawback is, of course, that when something goes wrong, you still need to know what's under the hood, and you still need to know your stack, right? So if you're dealing with Spring Boot, Spring Data JPA, that does not absolve you from knowing things about databases and transactions and SQL and all those other technologies. And this part is no different in that sense. All right, if we take a look at the UI, there are also a couple of things that make this tick. So if we look at the sources that are being there, let's take a look at the availability component, for instance. So what we see here is that the availability, or is it the inventory component? Let's take a look at the inventory component. So here we have the inventory component, which again it connects to the Stomp service for the WebSocket connection, and then it sets up a callback in order to be able to update the UI with the data that's being populated on the backend application, right? So on the backend application, the data is being streamed towards the Angular application, and the Angular application has a callback that will update the rows that as necessary. If we check the other one, the availability, I think that one is more traditional in the sense that it simply calls an API, or was it one of the other ones? Well, yeah, it's pretty simple to set this up, at least for a demo, of course. I mean, if you're going to build a full-blown store out of it, there's 1,000 or a million requirements more that you need to take care of. But this is giving a good indication of how you can use Redis, and also how you can use applications like Spring and Spring Boot together in order to make those reactive applications that can really respond well to what your customers want to see. And that is pretty much what I had to show for today.
So a couple of quick questions about the app that we've just seen there.
Sure.
You showed us the Gradle file. The first thing you showed us. So is that the thing that imports con.redis labs? It's a Spring Boot thing, isn't it? So is that the import statement? Is that what actually goes and grabs a Redis runtime and puts it in this app? Am I oversimplifying that?
Yeah. So Gradle. I mean, I don't know if you're used to Maven.
Yeah, I know. Yeah, I know what Gradle's basically saying. I've got Maven's horrible, isn't it? But Gradle's not so bad.
Yeah, I don't know. I think both have their advantages and disadvantages. So I like Gradle for its simplicity, but I like Maven also for its maturity. There's a lot. There's a Maven, but yeah. So this is where you specify all your dependencies. So this will bring in the jar from Maven Central or my local Maven.
Oh, I see. Okay. So that instruction there is basically saying, go in and get that. That's my dependency, and then that makes it available to the rest of the app. So that's okay. Brilliant. So that will go and get the Redis runtime and make sure it's in the correct context of the running app, so that all of the other components of my app can actually take advantage of that in-memory database. Yeah,
definitely. So this is, and it's good to know that what I showed here is the API application and the UI application.
Yeah.
But if we go into the Docker Compose YAML, here we can see, so this will create essentially one backend application and one web application.
Yeah.
But it also gets a Redis search distro from Docker Hub in this case.
Right, got it.
Where it's actually running the local Redis that is being connected to.
Perfect. So like all good apps that we can get from GitHub now, this is all self-contained. It looks to me like, because I've just pulled the repo down, I should be able to execute it. It should be fine, shouldn't it? Unless there's something badly wrong with my system.
Yeah, just make sure that you've got the right JDK and stuff like that. So that can be a couple of things.
You say that like that's simple, but that's a problem that's really hit me hard in the past.
Yeah, and JDKs they grow on trees these days, right? So they are being released every 6 months at least.
Yeah.
So there's a lot of them out of there.
Right.
Also, check out the front end application. It's built around Angular, and it's I think it's a bit of an older version of Angular. So I had to update 1 or 2 dependencies in there to make it work. But other than that, it was fine.
It's a great sample app, I think, to show everybody what this sort of thing does. So I mean, I'd say to everybody, if you've got time, just have a look at it and see how it's going. So thanks very much, Lars, and thanks very much everyone for coming.
All right, have a great weekend all.
Thank you, Lars.